Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome to Ekeeda. Today we will see problem number 6 on Thevenin's and Norton's theorem with dependent sources. Here you can see we have been given a circuit and we have to find current through this 10 ohm resistor. Also we have to find what is the power which is dissipated across this 10 ohm resistor. So for that obviously we need current through this resistor, then we can find the power. So now to solve this problem, we'll go with routine procedure. And after VTH, we'll find Norton's current, and after that RTH, that is Thevenin's resistance. And after we will draw the equivalent circuit along with this 10 ohm resistor, and then we'll get the required answer. So let us first do the step number 1, that is calculation of VTH. Now for calculation of VTH, we know that the branch through which current is required, we open that branch. So here, this branch between A and B, or this resistance between A and B, will be removed, and we will find the Thevenin's equivalent voltage between these points A and B. So we'll draw a new circuit with this resistance removed. So here I have drawn the equivalent circuit to calculate VTH, that is Thevenin's equivalent voltage. So first we can note few things. First of all, this A and B, this is open circuit. So we have to find the voltage between this A and B, which is called as VTH. There is something called as IX here, and that IX is also here in this second loop. We can call this as loop 1, loop 2, and loop 3. Loop 3 is open circuited. Here you can see this is Vx with negative sign at start. So we can also write what is the value of Vx. Vx will be, if you consider the current in this first loop as I1, which I will draw like this, I1. I'll call this current as I2, and we can call this as I3, but that I3 will be 0. That is definitely 0 because this is open circuit. So here, if you consider this loop 1, you can surely write Vx equal to minus because it is minus plus given. Then voltage is equal to resistance times current. Resistance is 1 ohm. So 1 into I1. Also, you can see that this current is Ix, and we have considered this current in loop 2 as I2. So I can write I2 is equal to Ix, or Ix is equal to I2. And now if you want to find I1 and I2, we can apply mesh analysis. That is, we can apply KVL to both loops so that we can get I1, I2. And then if we apply one more KVL here, we will easily get VTH. So we'll now apply KVL to loop number 1. Now while applying KVL, we know that this voltage source from minus to positive will go consider as positive. Then here this will be minus 1 into current I1. Here it will be minus 1 into I1 minus I2. And here it is going to be minus 4. So we'll write it with normal practice. Here in loop 2, again, if you follow this clockwise direction, you'll get plus 4, then minus 1 into I2 minus I1, then minus 2 into I2. I2 is nothing but Ix. Then again minus 1 into I2 because I3 is 0. And then this voltage source from positive to negative will be considered as negative. So we will solve the equation. First we will write the equation, and then we will solve both the equations. See, initially we have written this Vx with minus of I1, so we will substitute it now. And now we have both the equations, so we'll solve those equations simultaneously to get values of I1 and I2. So we got I1 and I2 both. Now we know that this I2 is nothing but Ix, so we can write. So in this circuit, now we know that what is Ix? Ix is equal to I2, so we can write what this voltage source is. We can also write what this, because this is 2 into Vx and Vx is minus 1 into I1, so we can write this voltage source also. So what we'll do, we'll first calculate the value of this voltage source and then we'll calculate what is VTH. Because we know that current through this loop is 0, we'll not consider this resistance. Here we have to consider the current because the current flowing is I2, and now we can apply in any direction. So if this is VTH, we'll apply the KVL. If you go in the same direction, this VTH will be now negative, so minus of VTH plus 2Vx. Then now we are going in clockwise direction, current I2 is coming opposite, so this voltage will be considered as positive. Then here there will not be any voltage drop because current here is 0, and this current or this voltage source will be negative because it is from positive to negative. So we'll write the equations according to law. So here it is going to be plus 2Vx, then here going to be minus 1 into I3 minus I2, and there will not be any voltage here, and then again minus of 10 into Ix. So we'll write that equation now. Now we will substitute the values of Vx as well as Ix. You can see here 2 into Vx is 1.6 volts and 10 into Ix is 4 volts. So we will substitute those values accordingly. So value of I2 is 0.4 amperes and 10 into Ix we have calculated, that is 4 volts. So we'll calculate VTH now. So here we are done with VTH, that is step number 1. Now we will go for step number 2, that is calculation of IN, which is called as Norton's current. So for calculation of IN, that particular branch is shorted. For VTH, branch is opened, we know it. So we'll draw the same circuit with AB branch shorted. So here I have drawn the circuit. So obviously we'll write the element values, but we can consider these currents as, you can call this as I1. And now, because we have written I1, I2 and I3 three currents, we can apply here again KVL to all three meshes and or these all three loops, and we can get this Norton's current by comparing or by solving those equations. So one by one, we'll apply KVL. Here also this Vx is nothing but minus 1 into I1, and this Ix value is nothing but I2. This is what we have to remember. So KVL to loop 1 will give us 2, then minus 1 into I1, then here will be minus 1 into I1 minus I2, and minus 4 equal to 0. you can see if we apply KVL, it will be 4 because minus to positive is positive. So 4 minus 1 into I2 minus I1, then minus 2 into I2. Well, this current I think here is Ix, which is given to us, which is same as I2. This is nothing but Ix. If you go for this one, this will be minus 1 into I2 minus I3. So this is our again equation number. So this is my loop number 3, and now I will apply KVL to this loop. You can see if I apply, I start from here, minus to plus will be positive, so plus 2 Vx minus 1 into I3 minus I2, then minus 2 into I3, then minus 10 into Ix, so on. So we'll write that equation now. Now we will rearrange the equation as well as the value of Vx, which is minus of I1, we will substitute it here. Now what is this Ix? That this Ix is from loop 2 and Ix is equal to I2. So instead of this Ix, we'll put I2. So now we will solve these three equations simultaneously to get values of I1, I2 and I3. So these are the values that we have got, I1, I2, I3. Now from the circuit we know that, you can see that I3 and IN, that is Norton's current, they are same. So we have got Norton's current. So we are done with step number 2, that is Norton's equivalent current. Now we have to find either we can call Norton's equivalent resistance or Thevenin's equivalent resistance. For that we know the formula is voltage upon current. So we'll find it. So finally we have got RTH equal to 7 ohms. And now we'll go back to our question. See, our question is find current through 10 ohm resistor. We have till now found RTH as well as VTH as well as IN. So now we will draw the equivalent circuit that all the voltage sources will be replaced by VTH and the whatever resistance is there will be replaced by Thevenin's equivalent resistance. So we'll draw the Thevenin's equivalent model. So let us now assume that current through this circuit is I, and that current will be voltage upon total resistance. So voltage is minus 2 divided by total resistance is 17. So this is the current which is required. It is with minus sign. That means the actual current is opposite of this. So you're done with the current through resistor. Now you'll see the next part of question. Power dissipated across this 10 ohm resistor. And we know that formula of power is I square into R. We know the value of R. We know the current through it. So power dissipated is I square into R. We'll calculate. And this I is nothing but the value of current which we just got. This value of current I is nothing but the value that we just got. We'll see that value minus 0.11 ampere, which we will substitute there. So here we are done with the power calculation, which is I square into R. So whatever was value of I, we squared it, multiplied by 10, that gave us 0.138 watts, and that is the end of question. So thank you very much guys for watching this video. Stay tuned with Ekeeda and please subscribe to Ekeeda. Thank you.